Good afternoon, everyone. Today we will continue the first section in the linear algebra. And since we start the first section before the holiday, now let's review a little quick the system of linear equations. Then we will start today's topic. So linear system. Linear m by n linear system. We have m equations, n variables, okay, n unknowns. So this is called the m by n linear system with all the aij and bi's as the real numbers. x1, x2 until xn are n variables. So this is the standard format of m by n linear systems. And be careful of those aij's, okay, aij's. And we introduce 2 by 2 system, right? 2 by 2 system, that is those two, the standard format. And actually each equation represents the straight line, right? Represent a straight line on the x1 or x2 coordinate system, right? And we give some examples, okay? We give some examples. So actually the intersection of those two straight lines gives the unique solution for this 2 by 2 system. And if those two straight lines are parallel to each other, then there is no solution existed. And if those two straight lines forms just as one line, that means we have infinite number of solutions for this 2 by 2 system. And also we talk about the equivalent system, right? Two equivalent system means they sharing the same solution set, right? Usually we are trying to transform a complicated system into a easier one, right? Easier one. And here we introduce the strict triangle form for the n by n system, and that is for the coefficient aij part. It should be looks like a triangle, right? In the case row, the first k minus 1 coefficient are all 0, and the coefficient for xk is non-zero, right? That is strict triangle form. And we are trying to transform a system, okay, a system into strict triangle form. Then in this way, for this equivalent system, we can use the back substitution method to solve it. That is easy, right? That is easy. Now let's looking at this 3 by 3 system, and we are trying to reach the strict triangle form, okay? And I will explain, okay? I will explain my method to solve this 3 by 3 system first, and then we will summarize it, okay? We will summarize it. Even though you can use your own knowledge or your high school knowledge to solve this 3 by 3 system, but just be patient, okay? Be patient to check my steps, okay, to check my steps, and we will summarize later. So first I'm going to mark those equations, number 1, 2, 3, okay, number 1, 2, 3, and then I will put some steps in this way, okay? I will put some steps. So if I combine two equations, I would like to cancel out x1, okay? I would like to cancel out x1. So how can I cancel out the x1? For example, okay, for example, for the first equation and the second equation. For the first equation, if I multiply by 3 for the first equation on both left and right side, so we have 3x1 plus 6x2 plus 2x3 equals 9. Then I use the second equation minus the first equation. Then I can get the coefficient for x1 becomes 0, right? So that is I will do second equation minus 3 times the first equation. Then the coefficient for x1 becomes 0, right? So let me write more details, okay? Let me write more details. So here, 3 times the first equation. So the first equation becomes 3x1 plus 6x2 plus 3x3 equals 9, right? Times 3 on both sides. It's the same, right? It's the same. Now, second equation minus this one, okay? Second equation minus this one. So for x1 that becomes 3 minus 3, right? 3 minus 3. This second equation minus 3 times the first equation means the left part minus the left part, the right part minus the right part, okay? So that becomes 3 minus 3 for x1, okay? And then x2 is minus 1 minus 6, right? And then plus x3 is minus 1 minus 3. And the right side constant is minus 1 minus 9, right? Then I can rewrite this equation, okay? This equation, x1, the coefficient for x1 disappears, so that becomes minus 7x2 minus 6x3 equals minus 10. So I only have two variables, right? I only have two variables, x2 and x3. Now, if I look at the first equation and the third equation, okay, step 2. If I look at the first equation and the third equation, I can also do the same thing to cancel out the coefficient for the x1. So the first equation times 2, and then the third equation minus the first equation, okay? So let's write 2 times the first equation. That is 2x1 plus 4x2 plus 2x3 equals 6, right? Equals 6. So the third equation minus this one. So for x1, that is 2 minus 2, right? For x2, that is 3 minus 4. And then for x3, that is 1 minus 2. And then the right side becomes 4 minus 6, right? Here, the third equation, 4 minus 6. Then we get a new equation, right? But only involving x2 and x3. So we get minus x2 minus x3 equals minus 2, okay? Equals minus 2. And here, maybe you will feel more comfortable to multiply by minus 1. But we are not going to do like that, okay? We are not going to multiply 1 minus 1. We will keep it, okay? We will keep it. Minus 2 minus x2 minus x3 equals minus 2, okay? So now my equation becomes, okay? Now my system becomes, so the first one I keep the first equation, okay? The first equation. And then my second equation becomes this one with only x2 and x3. So my voice is not loud enough. Equals minus 10. And then minus x2, the third equation becomes this one. So that is the new system, okay? That is the equivalent system for the original. So I will mark this one as 1 prime, 2 prime, 3 prime, okay? Those equations, okay? Those equations. Then I will do step 3, okay? I will do step 3. So here, the next purpose is trying to cancel out the coefficient for x2. Then I only have one variable. Then we can solve it, right? We can solve it. So step 3, I will do in this way. The third equation, okay? The third equation plus minus 1/7 times the second equation. Because here is for x2, we are going to cancel out, okay? We are going to cancel out. And I will based on the second equation, okay? I will based on the second equation. If here is minus 1, here is minus 1, so I will multiply by 1/7. That becomes minus 1 times x2. So I will do the third equation minus the second equation multiplied by the constant 1/7. Okay, 1/7. So let me write this one first. 1/7 times the second equation. 1/7. So that is minus x2 minus 6/7 x3 equals minus 10/7, right? So that is 1/7 times the second equation, right? Times the second equation. Then this third equation, this new third equation minus this one, okay? Minus this one. So for x2, that becomes minus 1, minus plus, right? x2. Multiple second equation by minus 7. I will based on the second equation. Okay, I will based on the second equation to do minus 1 to do 1/7. I will explain why. Okay, I will explain why later. So for x3, that is minus 1, so it's plus 6/7 x3. Okay, x3. And then minus 2, plus 10/7. So the equation becomes x2 coefficient becomes 0. So that is minus 1/7 x3 equals minus 4/7, right? Minus 2 is minus 14/7. So now it's easy to solve x3, right? It's easy to solve x3. So let me write the new system first, okay? The equivalent system, okay? Let me write the system. Let's check how it looks like, okay? The equivalent system. So the first equation is the same. x1 plus 2x2 plus x3 equals 3. And then the second equation is minus x2 minus 6x3 equals minus 10. And then the third equation becomes minus 1/7 x3. And only we keep those equations, okay? We do the for the step 2, okay? For the step 2, we multiple non-zero constant for the first equation. So we replace second and third equation, right? If you check first step and second step. So we multiple non-zero constant for the first equation, then we added, we subtracted it from second or third one. So the new equation can replace those second and third equation. And step 3 is the same. Okay, step 3 is the same. We are going to replace the third equation. So we will use the third equation minus a constant, okay, a constant or a fraction times the second equation. So then in this way we can replace the third equation. If you use 7 times third equation, we are not going to replace the third equation, okay? And basically that is not called the row operations, okay? So actually what we did here is the row operations. Now what is the format of this system? What is the format of this system? The equivalent, new equivalent system, triangle form, right? Strict triangle form. And what is the method? What is the method we can solve this system? Back substitution, right? Back substitution. So here it's easy, right? It's easy. X3, the third step, X3, the third equation, sorry, X3 is 4, right? X3 is 4. Then minus 7x2 minus 6 times 4 equals minus 10. So what is x2? X2 will equals minus 2, right? Minus 2. And then the first equation is x1 plus 2 times minus 2 plus x3, which is 4, equals 3. What is x1? X1 equals 3, right? X1 equals 3. So the solution will be 3 minus 2, 4, right? The solution for this system, that is 3 minus 2, 4, right? And what we did here, let me circle it, okay? Let me circle it. So what we did here is the back substitution, right? To solve the strict triangle form. Yes, yes. And we get the solution is 3 minus 2, 4, right? I will use this example, okay? I will use this example to explain the row operation, okay? To explain the row operation. How can we perform the row operation to reach the strict triangle form and its equivalent system, okay? After we perform the row operation, we still get its equivalent system, okay? Now, let's introduce the matrix format, okay? The matrix format first. So I have already finished this part, okay? I have, are they the same? Yes, they are the same. I have already finished this example. Now, let's just get an idea how the matrix looks like, okay? A matrix is a rectangular array of numbers. So for example, okay? For example, and we usually use the square bracket, okay? Square bracket to write it. So A11, A12, A21, A22. Rectangular array of numbers. So it's rectangular. We have the rows and columns. So for the matrix, we are going to call the rows and the columns. A matrix having m rows and n columns is said to be m by n matrix. Okay, m by n matrix. If m and n are equal, to each other, then this matrix is called to be square. Okay, is called to be square. And now if we are going to write the coefficient matrix, okay, if we are going to write all the aij for the m by n linear system, so we can write the coefficient matrix in this way. And we usually use the capital letter, okay, the capital letter ABC to denote the matrix. And it's usually the square bracket, okay, square bracket. So how can I write the coefficient aij? So the first row means the first equation, right? All the aij. So that will be a11, a12 until a1n, right? And then the second row, that will be a21, a22 until a2n. And the last equation will be m equation, am1, am2. The last one will be amn, right? Amn, this is m by n, right? What does this m by n mean? for the linear system, we have m equations, right? N variables, right? N variables. So actually the rows for the matrix, which means the number of equations, right? The m rows in the linear system, that means the number of equations, which is also m, right? The number of equations. And the n columns, that actually means the number of unknowns, right? The number of unknowns, or the number of variables. Now let's check all the Aij, okay? And we call the each element in the matrix is called each entry, okay? Let's check the Aij entry. So that means the entry is located. So now we understand much better what does the two-digit subscript mean for the Aij, right? That means the entry is located. That indicates the position, okay, of the Aij in the matrix. So this entry is located in the ith row and jth column, right? In the ith row and jth column in the matrix A, in the coefficient matrix A, right? Everyone is clear? Aij, what does Aij mean? So for example, A12, what does A12 mean? A12 is the entry in the first row and second column, right? A12. Then what does A21 mean? What does A21 mean? That is the entry located in the second row and first column. So don't be confused. They are different, right? They are different. And A1n, which means this entry is located in the first row, nth column. AM1, this one is located in the mth row, the first column, right? So that's why we said we should be careful to write the Aij, okay? The two-digit subscript for the coefficient Aij. Everyone's clear about the coefficient matrix, okay? Coefficient matrix. And that is the brief introduction about the matrix. We will talk about more details about matrix later, okay? And then the augmented matrix, okay? Augmented matrix means we put the coefficient matrix A on the left side, okay? On the left side, and put the right side constant B on the right side, okay? On the right side. So let's recall the m by n linear system first, okay? M by n linear system. Now it's easy to write all those equations, right? M by n linear system. So that is A11 x1 plus A12 x2 plus A1n xn equals b1, right? Equals b1. Second equation will be A21 x1 plus A22 x2 plus A2n xn, right? A2n xn equals b2. And then until the m equation am1 x1 plus am2 x2 plus the last one is amn xn equals bm, right? Equals bm. And we have already write the coefficient part as a matrix, right? As the coefficient matrix A. And then first we understand all the Aij and Bi's are real numbers, right? They are known. They are real numbers. The unknowns are all the xi's, right? All the xi's, x1, x2 until xn. They are unknowns and they are variable we are going to solve. So this augmented matrix put all the real numbers we know from this m by n linear system, right? That means this augmented matrix extract all the information of this m by n linear system. Okay, so if we can perform the row operation based on this augmented matrix, then we can solve the m by n linear system. Everyone's clear? So we understand in this augmented matrix, and they are equivalent. Okay, they are equivalent. So if we write in this augmented matrix, we know that this part, actually each column, the first column is the coefficient for all the variable x1, x2. Second column is the coefficient for the variable x2, and the last column is for the coefficient xn. That is the left part of the m by n linear system. And here the b, okay, b. We can write the b in this way, okay? b1, b2, bm. And you can take this b as a matrix, special matrix. We have m rows, just one column, okay? You can take this b as a matrix. Actually, you can call it vector, okay? More specific, that is a vector, that is the column vector. But the column vector is also a matrix, okay? Matrix. So you can take the right side constant as a special matrix, which is m row by one column. So the coefficient matrix A, and then put a vertical line at the right side constant B as another matrix. Okay, that is called augmented matrix. Okay, augmented matrix. So we can perform the row operation based on this augmented matrix to make this augmented matrix to reach the strict triangle form. Then we can go back to the linear system using the back substitution method to solve the linear system. Okay. And then, so next we need the row operation based on the augmented matrix. Why we do row operation? Because each row means each equation, right? Each row in the augmented matrix represents each equation in the linear system, right? Now let's check what are those three basic or elementary row operations. Okay, number one, interchange two rows. So for giving m by n system, if you interchange two rows, that is also called the row operation. Okay, we are not going to change it randomly, okay, or change it by your mind. We just keep the position. Okay, we keep the position of the m by n linear system. And number two, multiple row by a non-zero real number. We did that, right? In the previous example, we multiply by 2, multiply by 3 for the first equation, or multiply by 1/7 for another equation. That is something we did. Okay, multiple row. Okay, multiple row. Number three, replace a row by its sum with a multiple of another row. We also did that. Okay, for the third equation minus the second equation multiple by 1/7 to replace row 3, right? So those elementary row operations will transform the original system into a equivalent strict triangle system, which makes it easy to solve the linear system. Okay, to solve the linear system. So we will repeat that example. Okay, based on the row operations. Okay, based on the row operations. Now let me repeat this example. Okay, let me write this example again, and we are going to perform the row operation to solve that. Okay, so the equation is, this is 3 by 3 system, right? we have 3 equations, x2 plus x3 equals 3. And then 3x1 plus, minus x2. Minus x2, and then minus 3x3 equals minus 1. 2x1 plus 3x2 plus x3 equals 4. You can check your note, okay? You can check your note what we did before, okay? With those steps we did before. So first, write the augmented matrix. Augmented matrix, which is easy, right? Which is easy. So we write all the aij, 1, 2, 1. Let me write all the aij first. 1, 2, 1, second row, 3, minus 1, minus 3. Third row, 2, 3, 1. And all the bi's, right? All the bi's, b1, 3, b2, b3, right? So that is called the augmented matrix. Here is a vertical line to separate the coefficient and the right side constant bi's, okay? Then I will call those row 1, okay? Actually, row 1 is equivalent as equation 1, right? It's the same. Row 2 is equivalent as the second equation. Now, let's recall what we did before, okay? Let's recall what we did before. So here, my step 1, okay? My step 1. So be careful, okay? Be careful. My step 1, what I did. So I will use the second row, okay? The second row. What we did previous, I used the second equation minus 3 times the first equation, right? That is what I did before, right? And then I use the third equation minus 2 times the first equation. That is what I did before, right? Everyone's clear? I use the second equation minus 3 times the first equation, then I can cancel out the coefficient for x1. And then for the third equation, I will do third equation minus 2 times the first equation. Then I can cancel the coefficient for the x1 also, right? Now it's come to the row, okay? It's come to the row. So I will do those. Those are called the row operation number 3, right? Row operation number 3. I'm going to replace row 2 with the sum, okay? With this row, sum with the multiple of row 1. Okay, this is going to replace row 3 with its sum, okay? Sum with the multiple of first row, okay? First row. Now let's do the operation, okay? Let's finish here, then we take the break. So for the first row, let me use a different color, okay? Let me use a different color. And we will still write it as a matrix actually, okay? Use blue, okay? So the first row multiple by 3, I can get 3. The whole row multiple by 3, I get 3, 6, 3, 9, right? 3, 6, 3, 9. And then this second row minus the first row. So that is going to replace the second row. So I can write in this way. Okay, I'm going to replace. Let me change into red color. Okay, red color. So I'm going to replace my second row in this way. I will keep my first row. So my second row is going to replace by this row operation. So it will be 3 minus 3, 0. Minus 1 minus 6, right? The green numbers. Minus 1 minus 6, minus 7. Minus 3 minus 3, minus 6. Minus 1 minus 9, minus 10. We follow the operation here, okay? The operation here. Now, I'm going to replace the row 3 by these row operations, okay? Row operations. So let me choose a different color in yellow, okay? In yellow. So the first row will multiply by 2, right? Will multiply by 2, so I get 2. It's also red. Let me change into yellow. Okay, let me change into yellow. So here, row 3, okay, row 3. Sorry, first row. The first row times 2. So we get 2, 4, 2, 6. Okay. The reason I write a different color, small number here, that means usually we will do this operation in your mind. Okay, you just write a new matrix. So here is 2 minus the third row minus the yellow number. 2 minus 2, 0. What is the purpose of replacing these rows? Trying to get close to strict triangular form. Okay, trying to solve the equation. Why we discuss the linear system here, okay, or strict triangular form, the row operation, trying to solve the system. That is the purpose. So row 3, 2 minus green number 2, 3 minus 4, and then 1 minus 2. Right side, 4 minus 6, we get minus 2. Now, this is the new equivalent system after this row operation type 3. Then what does this new equivalent system mean? What does this one mean? If you take each row as a system, as an equation, so the first equation, as I said, this is the coefficient for x1, x2, x3, and this is the right side constant bi. So we can rewrite the system, the linear system for this augmented matrix. That is the system x1 plus x1 plus 2x2 plus x3 equals 3. And then what is the second equation? That is 0 times x1, right? 0 times x1, so it's 0. Minus 7x2 minus 6x3 equals minus 10. What is the third equation? Minus x2 minus x3 equals minus 2. Right? So that is the same as we did before, okay? We get the new equivalent system. And here, we didn't do anything. We didn't do anything for the first row, right? For the first row, it looks like we fix it, right? We fix it. So the first row we have a name is called pivotal row. Pivotal row. And how we decided the first row multiple by the number 3, multiple by the number 2. Based on this A11, this is 1. The coefficient for A11 is 1. Right? The coefficient for x1 is 1. The coefficient for x1 is 1. We are trying to eliminate those 3 and 2 as 0, right? As 0. So we multiply by 3, multiply by 2 to get those green and yellow numbers. So this one is called pivot, okay? Pivot. It's important, okay? It's important to perform the row operation to decide your pivot row and pivot. Now we have reached here, okay? We have reached this equivalent system, but it's not a strict triangular form for the coefficient matrix. And what is the next step? What is next step? We are trying to eliminate this position, this entry on this position 0, right? We are going to put this number as 0. Then that is the strict triangular form, right? So that is step 2, okay? That is step 2. And then we are going to fix the second row, okay? We are going to fix the second row and choose this one as a pivot, okay? Choose this one as a pivot. So this is pivot row. We are not going to do anything for the first one, okay? We need a strict triangular form, okay? Strict triangular form. So this is called pivot. So it's fixed. That's why we multiply by 1 over 7 to eliminate this one, okay? Eliminate this one. Or you can do some other row operation, okay? The row operation to reach the strict triangular form is not unique. You can interchange, actually here, you can interchange the second row and the third row, okay? You can interchange those, and then this one becomes the second row. That is the pivot row, okay? And then you can multiply by 7. In that way, we can also reach the strict triangular form. Of course, the solution will be the same, okay? The solution will be the same. So let me write the step 2, okay? Let me finish here, then we will take the break, okay? So step 2. What is my step 2? So I will mark those as a new row, okay? New row. So this is row 1 prime, and this is new, so new row 2 prime. This is row 3 prime. We will fix, we will not change row 1. And then since row 2 is the pivot row, it's fixed. What is the purpose? So that will be row 3. Row 3 minus, how can we decide the 1 over 7? Because we are trying to make this A32, this position is A32, become 0, right? So then times 1 over 7 times row 2. It's prime, okay, means a new row, new row. So in this new matrix, or new augmented matrix, from here to here, okay? The first one is fixed. 1, 2, 1, 3. The second one is the pivot row, so it's fixed. 0, minus 7, minus 6, minus 10. Then how can we do this one? Let me use green color, okay? Or you calculate in your mind, okay? Times 1 over 7. Times 1 over 7, this is 0 again, right? Times 1 over 7, this is minus 1, right? 1 over 7, yes, minus 1. And times 1 over 7, this is minus 6 over 7. This is minus 10 over 7. Right? So will be the third row minus those green numbers, okay? Third row minus those green numbers. So 0 minus 0, of course, it's still 0. Minus 1, minus, so plus 1, 0. We cancel out. And minus 1, minus, plus 6 over 7. 1 minus 1 over 7. And minus 2 plus 10 over 7, which is minus 4 over 7. Now how it looks like. How it looks like this augmented matrix, and we understand the left part is the coefficient matrix or the Aij, strict triangular form, right? Strict triangular form. And how can we write it as a linear system like this one? And how we solve x3, x2, x1 using the back substitution? Think about it. Let's take a break, okay? 5-minute break, then we will come back.